Roller coaster. You all have experienced and enjoyed a lot on roller coaster. During a roller coaster ride, guests experience a unique combination of sensations, whether it's being pushed into your seat or flung out of it. Roller coaster has been specifically designed to provide riders with a select combination of feelings. These feelings differ heavily at certain point of the ride, creating an overall experience that's unlike any other. In short, roller coasters are all about forces. The train undergoing a huge number of directional changes as they navigate the track, each of which provide a particular force and sensation on the ride. In this video, we'll get to understand the types of forces experienced on roller coasters as well as the sensation each type causes guests to feel during the thrilling ride. At this point, some of you may be asking the question, what are forces? A force can be described as a push or pull of an object as a result of an interaction with another object. In the case of roller coaster, the design of the track produces a force on the trains, causing them to follow a specific path. You will often see the term G-force used to describe the roller coaster. G-force, short for gravitational force, is a measurement of an acceleration and not specifically a force. However, a force and an object causes the object to accelerate. In the case of gravity, the force pulling everything towards the center of the earth causes object to accelerate downwards when dropped. The acceleration is denoted 1g force and causes the perception of weight as we know it. Therefore, a roller coaster which boosts a maximum of 5g force causes a rider to feel 5 times their normal weight as they are effectively experiencing an acceleration 5 times larger than that one pulling them to the center of the earth. During most roller coaster rides, guests will experience a range of gravitational force, each of which act in different direction. Linear gravitational force occurs in the forward and backward direction. Positive and negative gravitational force occur in upward and downward direction respectively, while lateral gravitational force occur from side to side in the left and the right directions. Linear gravitational force occurs as a result of an increase or decrease in speed. A great example of this is a launch as the train of the ride accelerates. Guests are subjected to linear gravitational force which occurs in the direction of speed. Change, however, as the train themselves begin accelerated and not the riders, guest becomes pinned into their seats. This allows for the riders and the train to accelerate together along the launch straight. A sudden reduction in the speed caused by a breakdown, for example, causes rider to travel forward in their seat until stopped by the resistance. Positive and negative gravitational force occurs in opposite direction. Positive gravitational force acts in the upward direction, while negative gravitational force acts in the downward direction. Positive and negative gravitational force occurs in opposite direction. Positive gravitational force acts in upward direction, while negative gravitational force active the downward direction, while the negative gravitational force achieve the downward direction. Both of the gravitational types can be experienced through a change in elevation. Rider would experience positive gravitational force in valley section of track which continuously angle towards the upward direction at the bottom of drop. Riders are often pushed down in their seat, causing them to feel heavier than normal. This type of force is usually most common on roller coasters. A ride which boosts a maximum gravitational force of 5 allows guests to experience 5 times the gravity of positive force at some point during this ride. Negative gravitational force, on the other hand, provides the opposite sensation as riders chase the hill of roller coaster at speed. They are subject to negative gravitational forces which pulls the train down, keeping them secure to the track. During this sections, riders often rise up and out of their seat, causing them to push down by the resistance. This phenomenon is known effectively as airtime. Roller coaster use a mixture of strong and weak and negative gravitational force to subject guests to a range of sensation. Weak negative gravitational force known as flow through time riders a sensation of total weightlessness, causing them to float in the air. Strong negative gravitational force known as ejector airtime causes guests to quickly rise up out of the seat, pinning them to the underside of their resistance. I checked, the airtime is much more aggressive than photo, often occurring at the top of the sharp hills. Finally, the last gravitational force type is lateral. Lateral gravitational force occurs from side to side in the left and right direction. It can often be experienced during the sharp turns in the track, especially ones that are unbanked. For example, wide mouse coasters, ones with flat, sudden turns produce high lateral gravitational force. As this occurs, riders are thrown to the side of the car in the opposite direction to the moment of the train. Extreme lateral gravitational force, however, are quite uncomfortable. Roller coaster design banks the track, which converts lateral gravitational force into positive gravitational force. This allows the ride to be more comfortable for the guest on the board. To recap, we have four main gravitational force groups. Linear gravitational force, which acts in the forward and backward direction, positive and negative gravitational force, which acts in upward and downward direction respectively, and lateral gravitational force, which acts in the left and right direction. Each group causes rider to move in the opposite direction to which the force acts. As you rise up out of your seat, as you experience downward pointing negative gravitational force, interestingly on a roller coaster ride, it isn't only the intensity of acceleration of force that affects the sensation felt by the rider. Sustained gravitational force, ones which last for several seconds, affect guests more than extreme spikes of intensity. To conclude, force plays a large part of a roller coaster ride. Designers ensure that the gravitational force experienced throughout the circuit are exciting, yet comfortable for all riders on board. So next time when you are on a roller coaster, take notice of the force experienced and how they move you in your seat. Thank you for watching. See you next time.